So right now, I'd like us to talk about deep learning. Um, Remember when we spoke of Geoffrey Hinton, uh, the scientist that was able to look at AI and say how, if we're trying to mimic human intelligence, which part of human intelligence, which part do we, you know, say represents human intelligence, and the organ that represents human intelligence is the brain. Um, so his inspiration was drawn from how the human brain works, and that is something that he wanted to put in place. So what Geoffrey Hinton was able to do was he wanted to design AI the same way as the brain works, which is human brain has neurons, and uh, neurons are able to get to get human beings to reason and think or and share information and process information in a much more detailed way. So it's not as similar as deep learning is not similar as machine learning, because essentially the reason why we put deep there is that we're getting more details. We have to think more of what you're saying. So remember when we say the child and gas, the child goes to the gas and touches it. Well, now, and we either show the kid an example of those flames so that they don't touch it, or we let them wander and discover. Well, now this one is a bit more complex. We make the child think about the decision of going to touch that stove or not, or even differentiate between, a flame that has just been drawn, it's not really burning, and a flame that actually burns, right? So it puts some thoughts and process to it. So as I said, it is drawn from an inspiration of how the brain is structured and how it works. So the same way we have neural in our brains that helps us make the decision, it's the same way in this case, we're trying to get computers to think a bit deeper, right? So, and this requires lots of data, because if I tell you from far that that stove is burning, you are not too close to actually see and feel the flame. You are not very far to not think it's not a flame. So you have to think and understand, is that flame live, or am I being just shown an image of it? Right? Now you have to think. Now you have to look at different things. You have to look at, um, are we indoors or outdoors? Is there a sufria on top or not? If there's a sufria on top or not, is it steaming? Can I see steam there, right? Is something boiling inside there? Can I tell from this distance that something is boiling and that gas is on, that gas stove is on? Now we have to think. That means we need more information. We cannot just look at at the at the flame and say, okay, it's on, it's burning, it's a live stove. At this point, now we have to think of, we have to factor in all those different items in order for us to make a decision, right? So we are more detailed when it comes to deep learning, and we pick out multiple features. We pick out multiple things that are happening before we make a final decision. So this is how it works. We're going to use an example of a cat and dog. So if you if you're someone who loves animals, or maybe you don't love animals and you don't even care for them, but you clearly know a cat and dog, right? So in this instance, in this instance where we have a cat and dog, most cat and dogs might actually not uh, might actually look alike. Some do not. Some look alike. So if you could see a cat and a dog, let's say let's put a scenario where it's a bit dark, right? And these two animals are not making any sound, and no voices at all. Then they stand together. Then they stand together in one place, and they're not your usual domestic cat and dog, right? Are you able to pick the difference between the two? if they are of the same size. If you see a cat and a dog that look alike, are you able to pick the difference, right? So you have to reason about how it works. So the same way we have to train a machine to know the difference between a cat and a dog, but from their features. So this is how your brain works in neurons. So different neurons pass different types of, there's lots of paths being taken in you making that decision. You start from the usual features that you know of. I'm just going to look at the sizes. If the sizes are similar, you're forced to think further. I'm going to look at the eyes, but they both have similar eyes, maybe orange or maybe orange eyes. And now you have to think again further. Um, I'm going to look at the wagging of the tail. Is it the same? I'm going to look at the ears. I'm going to look at uh, the cheeks. All that is factored in you making a decision, right? So after you think of all these features is when now you're able to make a decision between a cat and dog, right? So that means you need more data. You don't need the usual data of cats look this way, dogs look this way. Now you have to think about it, and you need more evidence for you to make a decision. So how significant is this technology? I'm just again going to share a video with you guys so that this will be more fun. So through a video, so you can see how much or how far, deep learning has gone. Our ability to now get into more details. What are the benefits of us creating a technology that is more detailed, creating a machine that is more detailed and keen? Suddenly we can be able to come up with multiple of things. We can be able to solve lots of things. We can be able to diagnose cancer. We are able to diagnose pneumonia. And we are able to diagnose that at a very early stage, So before we get to the video, some of the uses of deep learning is when you go on your web and you search for, when you try to translate your language, let's say Zulu to Swahili or English to Tswana or English to uh, French, any language that you might prefer, right? If you type in and if you type in anything in French, you type jamais and you translate it. What happens in the background to take that translation into uh, into English takes a lot for the machine. That is deep learning in action, because what happens is that it will take that journey, the thing that you've typed in French, and be able to look through different records and even annotations, because French is written differently from Kiswahili or from English, right? So there's that annoying apostrophe there at the top, right? That you have to factor in. And now it has to run through a whole library of French language and how it's spoken and its annotations, all that. And after doing that, be able to give you a reply in English, right? Which is never. Jamais in French translates to never in English, right? So that is one example. Another example is, in now to take it down further to some serious businesses, ability to know cancerous to know cancerous cells, if you have cancer at early stages or not. And that is something that is already being done, especially around lung cancer, where you go to the hospital, they scan you, and all those scans that are supposed to be looked at by a radiologist can now be passed through a deep learning machine and be able to give accurate predictions of your cancer. What stage are you in? Do you have any cancerous cells at any point in time?
This is how a radiologist diagnoses pneumonia.
84-year-old female, shortness of breath period, frontal and lateral views of the chest period.
This is an algorithm called ChexNet that's trained to do the exact same task. And this is how it performed against 6 doctors analyzing 50 chest x-rays for pneumonia in a recent test at Stanford. ChexNet is one of many projects exploring how artificial intelligence can take over tasks normally done by doctors. And it has some radiologists worried that AI could one day replace them. That's because algorithms are getting really good at interpreting images and diagnosing disease, sometimes with greater accuracy than humans.
We'll take a picture of this x-ray. The model will then run, and within a few seconds, it's outputted all these diseases, and they're sorted by the order of most likely to least likely.
ChexNet was given tens of thousands of images and told which ones have pneumonia and which don't. Then it trained itself to recognize patterns and identify pneumonia in new x-rays. This process is called deep learning. In 2016, computer scientist Geoffrey Hinton, also known as the godfather of deep learning, put radiologists on notice.
People should stop training radiologists now. It's just completely obvious that within 5 years, deep learning is going to do better than radiologists.
Part of the reason guys like Hinton say radiologists are replaceable is because they often work behind the scenes. Say you go to the emergency room with a really bad cough. The ER physician will order a chest x-ray, which is then read by a radiologist who gives a report back to the ER physician. Vice News spoke with Dr. Matt Lundgren, a radiologist at Stanford who's helping to develop new AI technologies.
As a patient, you're telling me that this process of reading my x-ray, which used to be done by a human, is now done by an algorithm. Why would I want this?
Well, so I don't feel comfortable with that, right? Would you fly a plane without a pilot? The situation that you just described is not one that has no physician in the loop. For narrow use cases, I think it would be a tremendous benefit as a patient to have, my doctor get information from some of these algorithms if they're shown to work.
What happens when the AI misses an important diagnosis?
It's something that comes up all the time. No matter what happens, if we are saying that we're going to use these algorithms clinically, there will ultimately be a time where an algorithm will make a mistake. The responsibility for the use of that algorithm will ultimately fall, I'm assuming, on a combination of the clinician and the healthcare system that's using this algorithm in that way.
Concerns aside, this research has created a gold rush for AI in medicine. All of it on display here at the annual meeting of the Radiological Society of North America.
So this is a super chill MRI that also uses artificial intelligence to compensate for movement of the body, like my breathing, and still get an accurate reading. Do you ever feel like you're training your replacement?
Yes, I hope so. I think in academic
really,
medicine...
you hope that this algorithm will replace you?
Absolutely.
Dr. Constance Lehman is a radiologist and Harvard Medical School professor who's also working with AI. She helped develop a model that measures breast density, a risk factor for cancer, in mammograms.
I am constantly teaching the next generation. So I have students come through. I hope they're smarter than I am. I hope they're better than I am. I hope they're stronger than I am. So in some ways, I may have sort of anthropomorphized this machine learning process.
This is your student. This
is my student. And she is relentless. She works 24/7. She never stops. She's looked at now over 200,000 mammograms.
And that efficiency has worried some doctors in training. In a recent survey of Canadian medical students, 29% of respondents agreed that AI would replace radiologists in their lifetime, and 68% agreed that AI would reduce the demand for radiologists. For context, there are an estimated 38,000 radiologists practicing in the US.
Is there a fear that radiologists will be replaced by AI?
There is a fear. So that's a very limited view of the role of a radiologist, because we do much more than search for patterns on images. And it's all those other aspects of the radiologist's job and our contributions to healthcare that will explode. AI allows us to expand our impact and expand access to people worldwide.
AI researchers say it will make radiology more accessible, lower costs, and save critical time in emergency care. But not everyone is convinced that the revolution is imminent. Dr. Paul Chang of the University of Chicago thinks AI will change his field, but cautions against all the hype.
We're seeing this gold rush right now. There are a lot of startups here promising to bring AI that'll revolutionize medicine.
Right.
How much of all of this is just hype?
Do you want me to be nice or do you want me to be honest?
Honest.
Honest? Most of it. But that's understandable. That's the normal process of this hype cycle that we always go through. In the gold rush, everyone went west thinking they could dig for gold. Most of those people failed or literally died. We have the same idea. We get seduced by use cases or applications. What will happen at the end of the day is we will learn to appropriately consume artificial intelligence to hopefully add value to our patients. I actually think the work that Stanford is doing is actually going to be helpful, and eventually we will use it, not because it outperforms me, but it's going to augment me.